Your notes consist of 4 practice problems, all of which I suspect we'll do in the Zoom. But just in case we didn't, or just in case you wanted to come back here and refresh your memory and get some additional instruction, here it is. If I want to graph this line, I start by writing the general form of the linear equation, y equals mx plus b. Then I identify b. Well, my line says y equals negative 5/2 x plus 4. So I'm adding positive 4, so positive 4 must be b. B is positive 4. You begin with b. B is the y-intercept, so b is the point where the line crosses the y-axis. So our line crosses the y-axis at positive 4. So you can put a point at positive 4 on the y-axis. M, in this case, M is negative 5/2. So M is negative 5/2. So delta y over delta x. Now here's the thing about a negative fraction. I can write it 2 ways. I can write it as negative 5 over positive 2, or I can write it as positive 5 over negative 2. Because negative divided by positive is negative, and positive divided by negative is negative. I can't write it as negative 5 over negative 2 because negative divided by negative is positive. This slope is negative. You can also start to think about, not start to think, but remind yourself some of the things we talked about, where positive slopes are uphill slopes, negative slopes are downhill slopes. So I don't know what this line looks like yet, but I know it's going to be some kind of downhill type of a thing. And the way that helps me is just to see whether my next point looks reasonable when I draw the line. So I'm going to use this version of the slope, but then I'll show you that we could have used this version and still get the same line. So you apply the slope from one point, the only point that you know, which is the y-intercept. So from this point, my delta y is negative 5. I move down 1, 2, 3, 4, 5. And my delta x is positive 2, so from here I move 1, 2 to the right. That point is on my line. Before I even draw the line, no, actually I'm going to do it first. My line's going to look like this. Really hard to draw a line on the writing tablet, but you can do it on your paper perfectly with the straight edge. If I had chosen to use positive 5 over negative 2, from the y-intercept I would have moved up 1, 2, 3, 4, 5, and then change in x is negative 2, I would have moved left 2. So you see that point is also on our line. And so if you have a negative slope, you can do it 2 different ways and you'll still get the same line. There's something tricky about this next one, but the start is the same. We always write y equals mx plus b. A couple tricky things maybe. What is b? What is the y-intercept? Look closely and think about that. This doesn't say plus 2, this says minus 2. So we have to rewrite it as x plus negative 2, because subtracting is the same as adding the opposite. And so b, the y-intercept for this line, is negative 2. My beginning point, my point where the line crosses the y-axis, is at negative 2. But the other tricky thing is, what is m here? Y equals mx, but all I have is x. If you see x, how many x's is that? It's 1x. And so sometimes m is 1. Often, in fact, m is 1. And so if you don't see a coefficient, if you don't see anything being multiplied by x, it's just 1x. 1x is x, right? That's the multiplicative identity. We worked with that a lot this year also. So if m is 1, when I try to represent the slope as a ratio of the change in y over change in x, it's just 1 over what equals 1? 1 over 1 equals 1. 1 divided by 1 equals 1. And so from my y-intercept, I'm going to move change in y up 1, change in x right 1, up 1, right 1. I can keep doing it. Up 1, right 1, up 1, right 1. All of these points are on this line. Y equals x minus 2. 1 is positive. The slope is positive. This is an uphill slope. Over here we had negative 5/2, downhill slope. By the way, we're not going to graph this one, but let me just pose a question. If I had y equals negative x minus 2, well, b is negative 2 again, but what is m this time? When you see negative x, what is m? Negative x is negative 1x, so m is negative 1.